something happens and you can't really get it right, and then you just want to throw your PC out of the window. You get really, really frustrated. Or maybe you're talking to a chatbot, you have some problems in buying something at an e-commerce site, but you can't really get the answer from the chatbot, and you just want to talk to a human being or anything, because the chatbot is so stupid. You feel like the chatbot or the computer doesn't really understand you. Or maybe more specifically, it doesn't understand your feelings. But now, what if we could change that? What if we could have our computers and our other systems understand us as humans? So we know from psychology that one really big part of interaction between a human to another human is emotions. So emotions are controlling a lot of our daily behavior. So this is the topic for today. So this is called effective computing. So in the next 35 minutes or something, I'm going to be describing both what we know from psychology, what is an emotion, how can we measure emotions, and then how can we do this by using artificial intelligence, and then how can we build this into our applications and also be able to use it as APIs that we just can call, and then we can get back an emotion classification of how we are feeling in this instant. So, but before we do that, I'm just going to say a couple of facts about myself. So my name is Håkan Silvnagel. I'm from Norway, and I'm actually almost hearing this other guy more than I hear myself. But anyways, so my background is in process automation. So I've been working with robotics and human-machine interfaces for a big process automation company. And also I have an academic background, which is quite broad. So I both have an engineering background, but also a psychology background. So that's what I'm sort of interested in this intersection between technology and psychology. So also been working a lot with user interaction and data visualization and these kind of things. And I've also taken a couple of classes at MIT in artificial intelligence and Internet of Things. But the reason why I'm having this talk is because in the last 2 years I've been studying psychology with a focus on emotions. And during these studies I came to the conclusion that there's quite a big divide between psychology and computer science as academic fields. So there are a lot of things that has been explored to a great extent in psychology, but that we as computer scientists, we are not really aware about these things. So effective computing is trying to bridge this gap between these two disciplines. So the question is here, what is effective computing? Or if you want to have like you can say that it's the human side of artificial intelligence. So if you want to have a more strict definition, we can say that this is the study and the development of systems and devices that can recognize, interpret, process, and simulate human emotions. So basically this is how can we have a much better and deeper interaction with our machines and systems, but also how can we do that between ourselves, also human to human. But in order to understand what this is, we need first to understand what is an emotion. So I'm going to give you some examples or some theories from psychology about what is actually an emotion and how can we measure these kind of emotions. But first we can say there are different types of things here. So one is called emotions. So what we in psychology we say that an emotion is a fast automatic response, and it's temporary, and these emotions are actually common to all people. So there is a set of emotions that we will have a look at a little bit further on in the presentation, which are common throughout all human beings. And we can contrast that to feelings. So in feelings, then we need to use our cognitive abilities. So we need to be aware both about the environment, and it's a thought process that is also involved. And I said that emotions, they were temporary, but feelings, they are much longer lasting. And then there's the third thing, which people are calling mood and affect. So this is if we combine feelings and mood and emotions together. So this is quite a complex field, and this could also be long-lasting. So throughout the history, there has been a number of different theories of emotion. So I'm going to just give you an overview of the four main principles of emotions. So the first theory is from the end of the 1800s, from 1880. So then there were two psychologists, James and Lang. They said that when we see some external stimuli out in the environment, then this will lead to a physiological reaction. And our emotions are only dependent on this physiological reaction. So for example, if you're out walking in the wood, and then all of a sudden you see a big grizzly bear coming towards you, then what will happen is you will start to tremble, and you will feel your heart rate is racing. So that's a physiological reaction. So it's this physiological reaction that your mind will interpret that this is fear. And you will conclude that, oh, I'm frightened. So it's not that you're not trembling because you're frightened, it's that you feel frightened because you're trembling. But if we think a little bit longer about this reasoning, we can see that there are some faults in this reasoning. So that would mean that in order to be able to feel emotions, we need to have some sort of physical reaction. But what about people that are handicapped or that are maimed and cannot move, for example? Can't they feel emotions? Sure they can. So a little bit further on here in the 1920s, there was a new theory by Cannon and Bird. So they wanted to challenge this first emotion theory by James Lang. So what they said that we feel this physiological response and our emotions simultaneously. And then there are signals in our brain that results in a physiological reaction. So what happens is you see a snake, and then at the same time you feel that you're afraid and you begin to tremble. And what is interesting here is that you can experience the same physiological response to different emotions. So for example, if you're sweating and your heartbeat starts to race, you start to respirate, then this is common both for fear, but also for excitement and for anger. So then in the 1960s, there was a new theory of emotion that is called the two-factor theory of emotion. So this theory focuses on two things here, that there is both a physiological response, but there also needs to be some cognitive processing involved. So an example here is that you walk alone in the parking lot to your car, and all of a sudden there's a strange man appears and approaches you. And what happens then is the first thing is that you see this strange man appear, and then you can feel your heart rate is starting to racing. And then this rapid heart rate is caused by fear. That is by your cognitive abilities will start to process this thing and figure out that, okay, so your heartbeat begins to tremble and you see this man. So this, we label this as fear. And then you get the conclusion that, okay, I am frightened. And then one of the more recent theories of emotion is from Lazarus. So what he said that first we need to involve thinking must occur before we can recognize the emotion. So if you see this bear in the woods, then you will think that you're in a great danger. And then you will have an emotional experience of fear and also a physiological response. So now we've had a short overview of the different theories of emotion. But then the next thing is here, how can we measure emotions? So in order to understand that, we also have to go back a little bit back in time to the 1800s. Then there was a guy that you surely know, Charles Darwin. He wrote the book, he called it The Expression of the Emotions in Man and Animals. So in this book, he claimed that these emotions, our emotions are universal across all human species. And he also said the emotions had an evolutionary history. And this was not so popular at that time, but he was actually right, as we will see a little bit later on. And at the same time in France, there was a French doctor called Duchenne. He did a lot of experiments on humans. So what he wanted to do, he wanted to write a book with the pictures of the faces of humans, so that he could say that if a human is reacting like this means that he's experienced fear, and if a human face reacts like this means that he's happy, and so on. So in order to do these experiments, he used electrical probes with a small current, and then he inserted these probes into the face of his test subjects. So what he found out was that he claimed that he could find 60 discrete emotions that he described in his book. And you can see some of them over here in the slide here. Then we go further down in history to more recent times, to the end of the 1960s. Then there was an American psychologist called Paul Ekman. He traveled to Papua New Guinea. So what he wanted to do, he wanted to study this thing that Charles Darwin has said, that there are universal emotions that are common for all humans. So he figured, what if I travel to some remote tribe? Would they experience the same kind of emotions as we do in the more modern world? So he selected this isolated tribe, and he found evidence that these facial expressions and emotions are actually universal. And based upon that, he built up something called an atlas of facial expressions. And this is also used today in psychology. So this is called the facial action coding system. But it's not only by looking at the facial expressions that we can determine what kind of emotions we have. We can also look at the body language, and we can also analyze speech. So you can analyze what kind of tone does this person speak in, and what is the intonation and pausation, what kind of rhythms does he have. And we can also use physiologic-based measures, like we can measure the heart rate or the skin conductance, or we can measure EEG and things like that. And by the way, here in this picture, we can also see there is some debate whether there are 7 or 9 universal emotions, but we can see some of them in these pictures that these are claimed to be universal all across the human species. So now when we know a little bit more about emotions and how we measure them, we can start talking about effective computing. So effective computing started at the MIT Media Lab. There was one of the researchers called Rosalind Picard. She wrote a book in the middle of the 90s that she called Effective Computing. And in this book, she started a whole new field of research. So at this time, this is an established field, so there are lots of research groups all across the world, and there's this IEEE proceedings and conferences and stuff like that. But she was the one who started it. And what she wrote in this book was that we could have machines detect emotions. So machines would be able to sense the emotional state of us, the user, by using both sensor and cameras and microphone. And it could also use speech recognition, gesture recognition, and image recognition. And it should be able to use machine learning also. But we have to remember that this was in the 90s, so a lot of this was actually science fiction. But I've heard some interviews with Rosalind, and she said that in the 90s, if she came to a big conference, people were looking strange at her and thinking, why is she here? What does she have to do in our conference? But now, some almost 30 years later, she's a very hot name, and a lot of conferences want her as a keynote speaker. So the question is, what has happened since the middle of the 90s and up to now? Why is it so that now we can use this effective computing and the ideas that Rosalind wrote down in her book? So the reason for that is that there are a number of enabling technologies. So one of them is that now we have cheap smart sensors that enable real-time data flow. And we are also able to handle all of these large amounts of data. So we have data lakes, we can store and process data in the cloud and so on. And we also have machine learning algorithms for most major cloud providers that we can just use as an API. So we don't really need to have a PhD in machine learning or be a data scientist. It's enough that we know how to call an API and how to make use of that in our application. So an example of this API is the Microsoft Emotion API. So with this API, what you do is you can analyze a picture, and then you will get back an emotion profile, as you can see here in this picture. So, for example, we can see that the woman on the left, she has 70% probability of feeling disgust, and the boy on the left, he has some 90% of feeling surprise. So there are a number of emotions that we can get out of the box. And these are corresponding to these universal emotions that I was talking about earlier. But it's not only Microsoft that has this service. All these major cloud providers has it also. So Amazon has something they call the Amazon Recognition API. And IBM has the Emotion Analysis API. And they also have something called the Watson Tone Analyzer. So we'll have a look at the tone analyzer in next slide here. So with the tone analyzer, what you can do, this uses text as an input, and then you get back a rating about what kind of emotions can we detect in this text. So you can see the more red the text is, the more anger probably is involved in the text. So now, how can we use this? Now, when we know that we can actually use machine learning and AI in order to detect emotions. So I'm going to take up a couple of application scenarios here on how this has been used in different industries. So one of the industries is in retail. So what you can do is you can have a store and you can equip the store with cameras. So the cameras, they will be registering in real time the facial expressions of the customers. And then you can have the clerks in the store can approach the customer in a much more appropriate way. So if they, for example, if they see that the customer is very irritated, they can be much more humble. Or if they see that their customer is really happy about something, they can try to sell him some more stuff if they want to. So the staff can use this information to enhance the customer experience and give a much better experience to the customer in the store. Another application scenario is in the medical field. So here we can use physiological measures to determine the emotional state of a patient. And by doing that, we can, among other things, we can reduce stress, which is an important factor for patients. So this means that the medical team can respond much quicker to the needs of the patient and handle him in a much more appropriate way. We can also have a look into the educational sector. So similar to in retail, we can also equip the classroom with facial expressions, camera that detects facial expressions. So then they can see if the majority of the students are feeling bored, then the teacher can change his teaching style and start to use a different method of teaching. And this can also be used in an online setting. And by the way, this has also been used, for example, if you want to, for example, have a computer game and you want to try to see so how much excitement does this induce in our users. You can use the web camera to detect what kind of feelings the users are experiencing when they are playing your game. And then the fourth scenario is in the social field. So in large parts of the Western world, a big problem here is that we have this growing population of elderly people, but we don't have enough young people and workers to take care of these elderly people. And in Japan, they have made lots of experiments using robots to socialize with elderly people. And these robots, they are using all of these things like facial recognition, speech recognition, and tone evaluation. And they also use physiological measures to be able to adjust their behavior towards these elderly people. So now I would like to take up what is in the very front line of effective computing. So there's a company called Effectiva, which also stems out of the MIT research lab. So they say that they have the world's largest emotion database. So they have 6 million faces across 87 different countries. So what they do is they offer this to us as an SDK and also an API, so that we can actually use their technology in our own products. So some examples of use case where this has been used is a virtual assistant that can recognize the motion of the user. You can also use it in, if you think about the self-driving car scenario, then you can have the car can actually detect what kind of mood state the passengers are in. So if he detects that, okay, these guys are actually quite angry, then he will just take the shortest path between these 2 points. But if they're in a good mood, he can adjust like the music in car, and he can also drive past some more scenic routes throughout the way. And also in advertising. So when you make an advertise, it's really important that you have the right timing, that at this exact point you want your audience to experience a specific feeling. And you also want to see how does that feeling linger out, like does it have a long phase that it lasts, or does it just drop like this? So Affectiva has been used in advertising research. So what they have also been used is in as an in-car protection system in order to detect if the driver starts to feeling sleepy, the Affectiva system can detect that and warn the driver that, oh, you're starting to fall asleep, you should wake up. So, so they use the same kind of technology for this. So for those who wants to try this out, there is a free app called FDexMe. So you can come up to me after this talk, or you can download it yourself. But I'm going to show you just a very quick demo here of how it can be used. So here we can see the emotion detector, and it detects both the gender, that I have glasses, and if you see up here, it detects the different kind of emotional states that I'm going through in this simple scenario. So then I would also like to talk about Pepper. So Pepper is a Japanese robot. So there's a company called SoftBank Robotics. So they are focusing on making robots that can adapt to humans. So Pepper was introduced in 2015. And he determines the emotions of the people around him by utilizing both voice and face recognition, and also body movements. And the way that he responds is both by changing the color of his eyes, the tone of his voice, and also the content that is displayed on the tablet on his chest. And Pepper has been used both in large banks in Japan, in Nestlé, Nescafé stores, and also in the railway stations across various places. And also, as of August last year, Pepper is using the Affectiva API for emotion recognition. So now one of the last things that I want to talk about is about collective intelligence. So collective intelligence is nothing new. So it has been known for a quite long time that a group of people has a much higher chance of achieving great results than a set of individuals. But can we find a single factor for this thing that's called collective intelligence? So there was some research that set out to try to find that. And maybe you think that's just the only thing that you need to do is to find people with a high IQ, some smart people, they will achieve the best results. But they found out that the IQ is only moderated correlated to this collective intelligence. So instead they found 3 different factors. So one is called the average social perceptiveness. And what that is, you can actually try this out yourself. But what it is that you will get a set of pictures where you can only see the eyes of persons. And then you should, by only seeing the eyes, you should be able to rate what kind of feeling is this person experiencing. So basically you're reading the emotions from the eyes of another human being. And they also found gender differences here, that actually women had a much higher social perceptiveness than men. And the second factor is the participation in group conversation. So here it's important that you don't have one person who's really dominant in the group conversation, but you let everyone in the group come forward with whatever they have to say. And the third thing that was important for getting great results is actually the proportion of women in the group. So the more women, the more intelligent groups. And this has to do with the social perceptiveness that I was talking about, that was a gender difference. Women on average are much more social perceptive than what men are. So what does this mean for us? So for us, it means that we need to be good at interpersonal skills, work together, but it also means that there's a big gain if we can design our computers to also be able to be more interpersonal, so that they can detect our emotions. So that is exactly what effective computing is all about. So before I summarize all of this, do we have any questions? Maybe
Questions? What questions?
Oh, okay. Well, if you have any questions, I will be here throughout the rest of the conference. Just come by.
Sure, thank you.
So so I have some. If you're more interested in this, I hope this has spiked your interest. You can read this some reference literature. One is the Effective Computing book by Rosalind Picard, and the other is a book called Blueprint for Effective Computing, and there's also the Oxford Handbook of Effective Computing. And if you want to reach me, you can either follow me on Twitter or send me an email. So with that, I want to thank you for your time.
Thank you so much. Cool, thank you everyone. We're going to have about 10-minute break and then